tutorial, I will explain to you how to calculate molar mass of a given compound. So before you start doing your calculations, you need to understand the data given to you in the periodic table. Some periodic tables, they place the molar masses or the average atomic mass, in this case, this one, below the symbol of the atom. So here, the number written below the name and the symbol of these elements in the periodic table represents the average atomic mass that if we round, we can get the molar mass. Whereas in some other periodic tables, you will find the number written. This one is a mass number, which we can also use as a molar mass, but it's written above the symbol of the atom. So in both cases, you need to understand that the larger number written in the periodic table goes for the molar mass, and the smaller number, I can use it, for the molar mass, and the smaller number will help me in writing electron configurations. For example, it's the number of electrons in that atom. Now, for those who are watching, any decimal number, it means that this is the average atomic mass. You can round this number and use it in your calculations. And in the periodic tables where you don't find any decimal number, it means that the given is a mass number, which I also can use as a molar mass. So let's now begin giving some examples in order to calculate their molar masses. So for example, I'm going to give you a question to calculate the molar mass of C6H12O6. So first of all, you need to understand the structure of this molecule. In this one, I have 6 carbons, I have 12 hydrogen atoms, and I have 6 oxygen atoms. In this case, the molar mass of this compound would be 6 times the molar mass of carbon, 12 times the molar mass of hydrogen, and 6 times the molar mass of oxygen. Now these numbers, you need to get them from the periodic table. So I'm going to use the periodic table in order to get the molar mass of carbon, hydrogen, and oxygen. If I use this table, the molar mass of carbon is 12, the molar mass of oxygen is 16, and the molar mass of hydrogen is 1. If I used this periodic table, the molar mass of hydrogen, I round the number, is also 1. The molar mass of carbon, I round it, is 12, and 15.99 is 16. So in both cases, it's the same number used. So 12, 1, and 16. Working out the numbers, 6 by 12, that's a 72. And here I have 12, and 6 by 16, that's a 96. So eventually, finally, the molar mass of C6H12O6 is 180, and the unit is gram per mole. Let's take another example. What if the question is asking you to calculate the molar mass of calcium carbonate? So again, you need to understand the structure of this compound. We have 1 calcium atom, we have 1 carbon atom, and we have 3 oxygen atoms. So in order to calculate the molar mass of this compound, it would be 1 times the molar mass of calcium plus 1 times the molar mass of carbon and 3 times the molar mass of oxygen. From the periodic table, whether I am using this table or the upper one. The molar mass of calcium is 40, the molar mass of carbon is 12, and the molar mass of oxygen is 16. If I used this periodic table, the molar mass of calcium is the larger number written below the symbol. If I round it, it is 40, and that of carbon is 12, and that of oxygen, I round it to 16. So I'm going to put the answer here. 1 times 40, 1 times 12, and 3 times 16. So the final answer would be 40 plus 12 times plus 3 times 16. 3 times 16 is a 48. And the final answer is 100 grams per mole. Now, the last example I'm going to give you in this video tutorial is a bit tricky. Let's say the molar mass of beryllium nitrate. How do I find the molar mass of beryllium nitrate? Let's first understand the structure of this compound. 2 here means that we have beryllium and twice the NO3, 2 times. So this compound contains 1 beryllium atom, 2 nitrogen atoms, and 6 oxygen atoms, 3 and 3. So I have 6 oxygen atoms. So when I want to write the molar mass of this compound, it's going to be 1 times the molar mass of beryllium plus 2 times the molar mass of nitrogen and 6 times the molar mass of oxygen. Using the periodic table. So, beryllium, here's the molar mass of beryllium. It's a rounded number, and as I mentioned, it's always the larger number. And here's the molar mass of nitrogen, and here's the molar mass of oxygen. If I am using this periodic table, here is the molar mass of beryllium, so I round it to 9. Here is the molar mass of nitrogen, and here's the molar mass of oxygen. So 14 and 16. So the molar mass of beryllium is 9, and 14, and O 16. So it is 1 multiplied by 9. It is 2 multiplied by 14. It is 6 multiplied by 16. So that's a 9, that's a 28, and 6 by 16, that's a 96. Therefore, the final answer is 133, and never forget a unit, gram per mole.